So is my screen visible to all of you?
Yes, sir.
Okay. So let's start the discussion, week 7 discussion. And the course Introduction to Soft Computing. Today is 21st March and my name is Ayan Paul. I am PMRF Research Scholar from IIT Kharagpur, and this course is Introduction to Soft Computing, taken by Professor Devasis Samanta of Department of Computer Science and Engineering, IIT Kharagpur. So let's move on to the discussion. Yeah, so today what I will be dealing with is concept of sharing in non-dominated sorting genetic algorithm, and concept of crowding distance in non-dominated sorting algorithm second, and then I will be moving on to neural networks. So what is the sharing concept in non-dominated sorting algorithm? So non-dominated sorting genetic algorithm, what we do is we sort all the solution in different. So okay, someone is joining. Okay, so what we do is we sort the population into different fronts. What is front? A front is a locus of point where neither a point is dominating, uh, where neither of the point is dominating. Like if this is a front, let me show you by this line. If this is a front, 1 2 3 3, then 3 to 12, and then 13. If this is a front, you can say that in this front no point is dominating and no other point. Like we cannot say that one is dominating 2 or one is dominating 3. Similarly reverse also we cannot say, like 3 is dominating 1 we cannot say, because here what we have to do, we have to minimize. This is minimize. We have to minimize f1 and we have to minimize f2. We have to minimize both f1 and f2, right? So if we compare this 2 point 1 and 2, you can say that in objective function 1, in objective function f1, this second point is dominating the first point. But what if we go on to the objective function f2? There you can say that this second point is dominating the first point. So that is true for all these points on the front. So that is why no point is dominating over another point. So this is a front. Similarly, this is a this red dots, they are forming a locus or the second front, and similarly this violet dots, they are also forming a front, that is third front. So now what we do in non-dominated sorting genetic algorithm is we give ranking to all this front, and we give the rank 1 to the Pareto optimal front. Now what is this Pareto optimal front? Pareto optimal front is locus of non-dominated front. So I think someone is joining now. Yeah. So this Pareto optimal front is a locus of non-dominated points. So so you can say that all the points in rank 1 are dominating over all the points in rank 2 and all the points in rank 3. Similarly, all the points in rank 2 is dominating all the points in rank 3, and all the points in rank 3 are non-dominating all the points in rank 1 and 2. So this is the thing. So how we do so after this what we do is we carry out proportionate selection, and when we carry out proportionate selection, what happens is, as this rank 1 is the most dominated front or the Pareto optimal front, you will get more copies of rank 1 rank 1 rank 1 points in your mating pool, and less points of rank 2 and rank 3. So that is how our selection pressure is ensured. Now what happened is, in GA we ensured two things. One is yeah. So in GA
कर ले फिर
in
स्टार्ट कर देना मैं ठीक है नेक्स्ट
Yeah, so what happens is in GA we ensure two things. One is population diversity and other one is selection pressure. So in step 2 you can say that as we are taking all the points of rank 1 only, so our selection pressure is ensured. But what about population diversity? The thing about population diversity is in this front, if you can observe, let me erase this first so it will be more clear. Yeah, so in this front what you are observing is this point 1, 2 and 13 are far away from all this point 3 to 12. So what happens, what will happen in this non-dominated sorting algorithm is you will get more points in the mating pool of 3 to 12 and less point in the mating pool of 1, 2 and 13. We will have less point in the mating pool and more point of 3 to 12. So so when this process happens, what happened is we are squeezing the Pareto optimal front and our population diversity is not maintained. So for this sharing function concept is introduced. So what happens in the sharing function is that first we find out sharing function of all the points in the front. So this Dij is Euclidean distance of one point with another point. Like if I say D 1 2, that means we are finding out Euclidean distance of this Euclidean distance between 1 and 2. So so after that we take a fixed value of sigma share. Sigma share is also, if you have studied in the note, there it was denoted as T share. So we tell it's T share or sigma share. So this sigma share we take it we take it as an imaginary share, and we tell that if this Euclidean distance is less than sigma share, then your sharing distance will be this. But if your Euclidean distance is greater than sigma share, then what happens is the sharing distance is 0. So why we are finding out this sharing distance? Because we have to calculate a thing called niche count. What happens in niche count is that the points which are far away, the niche count is niche count will be less for that point, and point which are very close to each other, niche count will have higher value. Niche count is probably like how many neighbors are surrounding that point. So if the neighbors are surrounding more like 1 to like this 3 to 12 points, the this these points are crowded by neighbor point more. So that is why the niche count for all this point 3, 4, 10 and 11 have higher values, whereas niche count of 1 to 12 and 13 have less values. So after when we find this niche count, we found the shared fitness. So shared fitness is individual fitness by niche count. So individual fitness is also called as dummy fitness. You can say it as dummy fitness. Dummy fitness. So dummy fitness by niche count. So we just now found out that the niche count of 3, 4, 10 and 11 point will have higher values. So in this you can say that see that if we increase the niche count, so the shared fitness is less, whereas for 1 to 12 and 13 1 to 12 and 13 this niche count is less, so shared fitness will be more. And now if proportional selection is carried out based on the shared fitness, there is more chance of getting more copies of 1 to 12 and 13. Thus this point will maintain a population diversity. So this is what we do in non-dominated sorting algorithm, sorting genetic algorithm first. So is this clear? Am I audible? Hello, am I audible, guys?
Yes, sir.
Okay.
Yes, sir.
Okay, so is this clear? Like something you got? I will explain you with a numerical example that will be more clear. So again, let me repeat the steps. What happens in this non-dominated sorting genetic algorithm is that first we make the fronts of all the solution. We make the fronts. We distinguish the points in different fronts. What is a front? Front is a locus of point where where two points are needed dominating each other. Like this white points are making one front, this red points are making another front, this violet colors are making another fronts. So non-dominating each other means you see here we are to minimize both the function. We have to minimize f1, we have to minimize f2. Now you can see here is that when we are comparing this point 1 and 2, or you can compare any point of this front like 1 and 13 also you can compare, but let me for convenience let me compare this 2 point 1 and 2. So what happens in this 1 and 2 point is that if we see this f1 function, we have to minimize the f1 function. So for f1 function this point 1 is dominating over point 2, but for this f2 function we have to again minimize this f2 function. So in f2 function this second point is dominating the first point. So that is why you can compare with all the points 1 2 3 4 12 13. You can compare with any 2 points and you will see that no point is dominating over no other point. So that is why this is a this points of white points are constituting a front. Similarly this red points are also constituting a front. Similarly this violet points are also constituting a front. Now what if we compare the three fronts? When we are comparing the three front, we can see that this front or 1 to 13, this front is dominating the other two front. Like this white front is dominating the red front and this red front is dominating the blue front, and this white front is also dominating this blue or violet front. So thing is that what is a Pareto optimal front? A Pareto optimal front is a locus of points, locus of non-dominating points. So non-dominating points are what 1 to 13 are the non-dominating points, and this when this is making the locus or this is making the front, we call it Pareto optimal front. So in this non-dominating sorting algorithm, what we do is we first do the ranking of these fronts. So the Pareto optimal front is given rank 1, then the least dominant front is given the highest rank, whereas most dominating front is given the lowest rank. So I think this step is clear to all, right? Is this step clear?
Yes, sir.
Yes, sir.
Okay. Now second step what non-dominated sorting genetic algorithm, what we do is we carry out a proportionate selection. Proportionate selection you all remember, like Rowlett-Weed selection. So what happens in this proportionate selection is the points which have lowest rank, like 1 to 13, this have lowest rank. So this points will have more copies in the mating pool than the other two rank points. So by this what happens is selection pressure is ensured. So up to this all good. But what happens is we encounter a problem in step 3. Step 3 is in genetic algorithm we have to take care of two things. One is selection pressure, another is population diversity. So in this third step we encounter a problem when we check for the population diversity. What happens is within this front, that is within this Pareto optimal front, what happens is you can see the points 4 to 12. 4 to 12 points are very close to each other, and 1 2 3 and 13 point that are far away from each other. So when this proportionate selection is carried out, what happens is that your front will have less less points which are far away, like 1 2 3 and 13. You have less copies. You have less copies in your mating pool. So this is the problem. So by this problem we can say that our population diversity is not maintained, right? Our population diversity is not maintained. So we take the help of this sharing function. So what is the sharing function? Sharing function basically gives you the thing that how much your point, how much any point is surrounded by more neighbors. Like you can see that the point 4 to 12 is surrounded by more number of neighbors, whereas 1 to 13 are very far away, so they do not have that much neighbors. So that is why you can see sharing function has this formula: sharing function of any point dij is I is one point and j is another point, and dij is basically Euclidean distance of this point. So sharing distance you can calculate by this formula. So after you calculate sharing distance for all these points, you have to find out this niche count. What is niche count? Niche count is summation of sharing function values of a particular point. So when you will find this niche count, you will find out that 1 to 12 and 13 will have less niche count because they are less surrounded by other point, whereas this point 3 4 10 and 11, they have more number they have more niche count because they are surrounded by more number of points. So by this you can see that this, and then you have to find out this sharing fitness. So sharing fitness is what? Sharing fitness is individual fitness by niche count. So so niche count, you can see niche count of 1 to 12 and 13 will be less. So if your denominator is less, then and this dummy fitness is equal for all the points, then your sharing fitness will be more. So sharing fitness will be more for this 1 to 12 and 13. So if the sharing fitness will be more, then this points 1 to 12 and 13 will have more copies in the mating pool. So by this our problem of population diversity will be solved. So this is the concept of sharing fitness. So is this clear?
Yes, sir.
Okay, so let me give you this concept with a numerical example that will be more clear. So this is the numerical example. So this is a front we have been given, and we have been given with 5 points: 1 2 3 4 and 5 points, and you have coordinates for all these points. So in this figure we can see this, that 2 3 and 4 point are very close to each other, right? But first point and fifth point are far away from each other. So when your solutions will take part in that proportionate selection scheme, what will happen is your solution will have more copies of 2 3 4, and your solution will have less copies of 1 and 5. So what will happen is your Pareto optimal front will be squeezed, and we do not want that. So to counter that, what we do is we will do that sharing function calculation thing. So sharing function calculation thing, how we will start? We will take one point at a time. So let's start with this first point. So when you are taking the first point, what you have to do? You have to find out Euclidean distance of this point with respect to all other points. Like you have found out Euclidean distance of d12. This formula you all know, that is x2 minus x1 whole square plus y2 minus y1 whole square. So by this you can find out the distance between this point and this point, and this is coming a 4.12. Similarly, you can find Euclidean distance of first point with respect to third point, then Euclidean distance of first point with respect to fourth point, and finally Euclidean distance of first point with respect to fifth point. So these are your values that are coming. D12 is coming 4.12, D13 5.38, D14 6.71, and D15 is 9.90. and we have to take one sharing function. If no sigma share is given, you can assume your sigma share, otherwise this thing is given in the question. So here we have assumed the sigma share as 6. So what happens with this is, when the sigma share when the sigma share is less than any of the Euclidean distance, in that cases the sharing distance will be 0 by this formula that I have just told. Here you can also see that if this first formula is applicable whenever this Euclidean distance is less than sigma share, but when this Euclidean distance is more than sigma share, your answer will be 0. So that is why you can see this Euclidean distance D14 and D15 are greater than 6. So that is why sharing distance for D14 and D15 are 0. I think someone is joining. Yeah. So sharing distance of these 2 points D14 and D15 is 0. But the other 2 points, that is D12, D13, you can see that Euclidean distance of D12 as well as Euclidean distance for D13 is less than your sigma share. So you will apply this formula to find out the sharing distance, that is 1 minus Dij by sigma share whole square. So in this 2 you are getting sharing distance of D12 as 0.53 and sharing distance of D13 you are getting 0.19. And here only I have told you that niche count is summation of sharing function values for a particular point. So we will find out niche count. So niche count, how we will find out? We will just add all this sharing distance, that is 0.53, 0.19 plus 0 plus 0. So when you will add this is your niche count for 0.1. Is this step clear to all of you?
Yes, sir.
Any doubt in this step? Anyone? You can interact. This is very important. Any doubt in all the things that I have told you till now?
No, sir.
Okay. So we will be doing similar for all the points. So we have done in this slide, we have done for point number 1. Now we will do for point number 2 same thing, that is we will find out Euclidean distance for second point with respect to all other points, that is 21, 23, 24 and 25. So these are your Euclidean distance. Here you can see this 6.71 is greater than 6, so that is why sharing distance for D25 is 0. And other points that like D21, D23 and D24, you will find out the sharing distance. And again niche count is the summation of sharing distance values for all the points. So this is the sharing distance values of all the points, and when you will add together you will get niche count of 0.2. Similar thing you will do for 0.3. 0.3 you can see you will find out D31, D32, D34, D35. So this thing you will find out, and same thing, and you will find out niche count for 0.3. Similarly you will find niche count for 0.4. This is niche count for 0.4, and similarly this is niche count for 0.5. So let's compare the values of niche count. So for niche count for 0.1 is coming 0.72, right? 0.1 is very far away and 0.5 is also very far away. So niche count of 0.1 is coming 0.72. Similarly niche count of 0.2 is coming 2.24. For 0.3 is coming 2.26, and 0.4 is coming 2.24, and 0.5 again coming 0.72. So what we are seeing here is that see 0.1 and 0.5 are very far away from all the other points. So niche count of 0.1 and 0.5 is coming 0.72, right? So नीचे count of 0.1 and 0.5 is coming very less, but about other points you can see नीचे count of all these points are coming 2.24 approx, right? 24, 26, etc. So now what we do is we will find the sharing fitness. So how we will find the sharing fitness? Sharing fitness is a dummy fitness divided by niche count for the respective point. So sharing fitness of 0.1 is we have taken this dummy fitness as 100. So sharing fitness of 0.1 is coming 138.89. Sharing fitness of 0.5 is also coming the same 138.89. But sharing fitness of all this 2, 3 and 4 are coming 44.64, 44.25, 44.64. So here we can clearly see that as our sharing fitness of 0.1 and 0.5 are greater than sharing fitness of all other points, so we will have more copies of 1 and 5 in the mating pool. So by this our Pareto optimal front will not be squished. So is this clear? Is this question
Yes,
clear?
sir.
Any doubt?
Yes, sir.
Any doubt regarding this question? Anyone? Any doubt?
No, sir.
Okay, so this is what sharing fitness concept in NSGA-I. So what happened in NSGA-I is that there are some limitations of NSGA-I. One is that the time complexity of NSGA-I is very high. Why? Because you can already see we have to do all these steps, right? We have to first find out the Euclidean distance, then sharing distance, then niche count, and then shared fitness. So time complexity of this NSGA is very high. So if we are facing that much time, similarly the computer will also, your computer program will also face more time. So for this, what the scientists have done that is that they have found another concept called crowding distance, and this they have applied in another genetic algorithm known as non-dominated sorting genetic algorithm, NSGA-2. I think someone joined. Yeah. So what I was telling is that NSGA-I has some certain limitations. The main limitation was that NSGA-I is taking more time, or it has more time complexity. So to counter that time complexity, the scientists have worked on another genetic algorithm known as non-dominating sorting genetic algorithm 2. So in this, what they have done is they have replaced this sharing function. We have seen in this question, as the sharing function is very lengthy, right? First you have to find out Euclidean distance, then sharing distance, niche count, and then shared fitness. As this is a 4-step process, right? So now what they have done is they have just they have replaced this 4-step process in 1-step process. So they have changed the sharing function to a thing called crowding distance approach. So what is this crowding distance? Crowding distance of a point I is the perimeter of a rectangle or cuboid. You can say this is a 3-dimension space, you can say cuboid, otherwise you can say rectangle. Perimeter of a rectangle surrounding this point. So this I point is surrounded by 2 points, right? I minus 1, I plus 1. So when we are finding this rectangle, finding the perimeter of this rectangle, this is crowding distance. So again you can see, if a point is very far away from other point, then the crowding distance will be very high, and if a point is very close to other points, the crowding distance will be more. So the solution will having more crowding distance values will be preferred in the reproduction scheme to form the mating pool. Again the same thing, like if the point is very far away, then the copies of that point in your Pareto optimal front will be less in the reproduction scheme. So to counter that, previously what we have used is sharing distance. Now what we are using is crowding distance. So now let's explain you by a numerical example. So here again I have taken 5 points. This is the first point 1, second point 2, third point 3, fourth point 4 and fifth point 5. So all this coordinates are given. For first point it is 1,8, for second point it is 2,4, third point 3,3, fourth point 4,2 and fifth point 8,1. Now crowding distance, as I have told, crowding distance of any point is a perimeter of the cuboid or rectangle surrounding the points. So this, someone is joining. Okay. Yeah. So first point, the problem with the first point is that we do not have a crowding distance is only applicable if a point is between 2 points. Like I have told you, if I point is between 2 points, that is I plus 1 and I minus 1. This is I minus 1 point and this is another point I plus 1. So this is a point, this is a point and this is a point. So if we have to find out crowding distance of I, what we have to do is we just draw a rectangle that is surrounding the point I. So I is surrounded by 2 points, I plus 1, I minus 1, and we will be drawing a rectangle and finding the perimeter to find the crowding distance. But the problem with this first point is that you can see there is no other point here, right? There we cannot see a point here. Similarly, this is the problem for the last point, that is fifth point. We cannot see a point here. We can see the first point 4, but we cannot see the last point. Like we can see the first point I minus 1, but here we cannot see the last point, that is I plus 1. Similarly here we are not seeing the point I minus 1, but we are seeing the point I plus 1. So for this, as we are not finding any other point here, as well as we are not finding any other point here, we are assuming that there are other points that are very far away from this point. That is why we are taking the crowding distance of first point, as well as we are taking crowding distance of fifth point as infinite, and other points we can find out this crowding distance. Like when we are finding the crowding distance of 2, so you take this rectangle, right? This rectangle which I have tried to highlight this rectangle. So this rectangle, how we will find the perimeter? Perimeter is twice L plus B, right? This is the perimeter of a rectangle. Perimeter is to twice L plus B. So length, how we will find out? This is 1,8 and this is 3,3. So 8 minus 3 is 5, right? And breadth, how you can find out? Breadth you can find out is 3 minus 1. 3 minus 1 is 2. So what is coming? Twice length is what coming? 5. Twice 5 plus breadth is coming 2. 3 minus 1 is 2. So twice 5 plus 2, that is 5 plus 2 is 7. 2 into 7 is 40. So this is perimeter or the crowding distance for point 2. Similarly, you can check the crowding distance of point 3. Similarly, you can check crowding distance of point 4. So here in one step only you can see this, as the crowding distance of point 1 and point 5 are very high. So that is why your mating pool will have more copies of 1 and 5, and that is how your Pareto optimal front will not be squeezed, or its spread will be maintained. So is this clear?
Yes, sir. Clear.
Any doubt, anyone, in this? Why we are using NSGA2 over NSGA1? Any doubt? Again I am repeating, here we are achieving our solution in only one step, by crowding distance. There we have to first find out sharing distance, then niche count, then sharing fitness. So that is a 3-step process, 3 or 4 step process, and this is only a 1-step process. That is why we are preferring NSGA2 over NSGA1. Okay.
Okay, sir.
Okay, so let's move on. So finally we have completed our genetic algorithm. So in the first class itself I have told you soft computing is composed of 3 things. One is fuzzy logic, second is genetic algorithm, and third is neural network. So we have completed fuzzy logic, we have completed genetic algorithm, and now we will be we will be shifting our concentration to this neural network. So artificial neural network. So in human brain, how our information is processed? Our information is processed by elements called neuron, right? And this neuron are connected to each other to process the information. So by mimicking this, what scientists have done is that they have produced artificial neural network similar to mimicking or similar to biological neurons or biological nervous system. And the artificial neuron is also known as perceptron. So let me show you this by drawing an analogy between biological neuron and artificial neuron. So the above one is a biological neuron and the below one is your artificial neuron. So biological neuron, this is the structure of your biological neuron. So biological neuron mainly composed of these 4 things. One is dendrites. Dendrites are this hair-like structure. This 1, this 2, this 3, and this 4. These are your dendrites or hairy-like structure. These are known as dendrites. Then we have a cell body. This black color thing is known as cell body, right? And cell body, or you can see this whole thing is cell body, and this black color particularly, this is the nucleus of the cell body, and this branch like structure is known as axon. So how we have made our artificial neuron comparing to a biological neuron? What we have done is, first we have given this inputs. We have given some weights to this inputs, like we know that in a process not all the inputs are equally effective, right? Some inputs will be more effective than the others. So we have given weights for all this inputs, like we have given weight for this x1, we have given w2 weight for this x2, we have given w3 weight for this x3, and similarly wn weight for this xn. Now all this is going to the similar to dendrites, like dendrites also, like this dendrite is carrying some weight, this dendrite is carrying some weight, this dendrite is carrying some weight, and this dendrite is carrying some weight, right? And all these dendrites have some previous inputs, like all these dendrites has some input, like this dendrite also have some input, this dendrites also have some input, this dendrite also have some input, and this dendrite also have some input. So all these dendrites are giving this information to the cell body. Similarly in our artificial neuron, all this branches or all this inputs are summed together in a unit called summation unit. This is the summation unit. This is the summation unit. Now this after this information is summed, like here what happens is we do sigma x I w I, like what we are doing, we are summing all the inputs multiplied by its weight, like x1 w1 plus x2 w2 plus x3 w3, similarly xn wn, all the information we are summing. Similarly in biological neuron also, all the information from dendrite are summed in this cell body. Now after this what happens is we are getting some output, right? When we are doing this sigma xi wi, we are giving some we are finally achieving some value. So what this part of your neuron check is that whether this value is greater than or less than a specific value called threshold value. If your value is greater than a specific value, like for example your threshold value is, let's say, 0.5. So after the summing, if our value is greater than 0.5, then the neuron will pass the output, otherwise the neuron will not pass the output. Similar to here also, like if your information, if your action find out that your information is important, then only this action will transmit the information to the next neuron. Like this neuron, there will be many neuron here also, here also. So this action will be transferring this information only if this information is of some importance, or this information will be more than a threshold value. For example, this is for example only. This is for example only, right? So if your output is greater than this threshold value, then your neuron will pass that information, otherwise the neuron will not pass the information. So this is the analogy between biological neuron and your artificial neuron. So is this clear? Is this slide clear?
Sir, again, please say that what is the use of threshold unit?
Yeah, what is the role of threshold unit? Okay, very nice question. So you see this neuron, right? This is a biological neuron. So in what is happening in this biological neuron? All the dendrites are collecting some information and it is giving to this cell body, or this cell body is also called soma. It is giving all this information to this cell body, and then this information is passing on to this axon. And your information, like this neuron, there will be many neurons. Our brain normally consists of 10 raised to the power 11 neurons. So like this there will be more neurons attached, but your information will only pass if it has some importance. Only after this your information will pass from this neuron to this neuron. So in biology, what will happen is that this transfer takes place with some voltage, kind of thing. Like if this input is greater than your input is more important, then only that voltage will be generated, otherwise that voltage will not be generated. So this is how our biological neuron work. Now what about our artificial neuron? Up to this step I think it is clear that the information that is coming from each input, that this summation unit is summing up. But if your information summing up by this sigma xi wi, but if your output from this end, like let's say O1, if your output is less than some specified value, for example I have taken this threshold 0.5, so if your O1 is coming like 0.7. So then only your information will be passed or you will get a output. But what happens if your output O1 is less than 0.5? For example, your output will be 0.3. So in that case, your neural network will not pass the information. Like your neural network for 0.3 will be giving 0 as the output. Okay, so this is the concept of threshold, that if your output is greater than the threshold value, then only your neural network will show some answer. Otherwise, if it is less than threshold value, your neural network will not pass the information or it will not show any answer. Okay.
Okay, sir, got it.
Okay. So now we have transformation function. So here I have what I have told is threshold unit. Similarly of threshold unit, there are other neurons also. In place of threshold unit, there is some transfer function. In place of this threshold unit, we have transfer function or transformation function, also known as activation function. So these are the four popular activation function. In first activation function, you can see here is that if your output or this O1 that I have told you, this O1 is less than this theta, in that case we will be getting answer as 1. Otherwise, if this O1, or here it is denoted by L, if this L is less than or equal to theta, here we will not get any answer or we will get 0. So this type of transfer function is known as hard limit transfer function. Similarly, we have another transfer function known as signum transfer function. This is very similar to this hard limit transfer function. Only difference is that here when this output O1, or here it is L, if this L is lesser than or equal to theta, here what happens is we are getting this output as -1. Here we are getting this output as 0 when L is less than equal to theta. Here in place of 0 we are getting -1 for this signum transfer function. Similarly, we have other two transfer function. These are some complex level transfer function. One is log sigmoid transfer function and the one is tan sigmoid transfer function. So this is the formula for this. Like when you are getting the O1 or this output or this small l, you put this O1 here and the answer you will get, that will be your output. Similarly, what you are finding this O1 here, when you put in place of L, you will get this output. So this is known as log sigmoid and this is known as tan sigmoid. So these are the four main transformation function, also known as activation function. So is this clear? Is this slide clear? Am I audible, guys?
Yes, sir.
Okay. Now some neural network architecture. So what I have discussed till now, we have seen the function of a single neuron. Similarly, there will be many neurons in a layer. So when all the neurons are connected in a layer, that is known as neural network architecture. So popularly we have three neural network architectures. First is single layer feed forward neural network. Here you can see there is only one layer of neuron, right? This is only one layer of neuron, and what happens is that we are giving the inputs to all the layer. Like when we are giving x1, this x1 will have some importance for this neuron, right? So that importance is we have given by this weight w11. So this is x1 into w11. This, if I tell you about this neuron, so this neuron will have the importance of x1 as w11. Similarly, x2 as w12. Similarly, x3 as w13. So what will happen is that here what will happen is that summation will take place, and then this sign, that means activation or transformation will take place. So how summation will take place? Summation for this neuron will be x1 w11 plus x2 w12 plus x3 w13. So when we will add all this, you will get this input, right? This is only input, but how we will get this output? Output we will get if we will give this input in a transformation function or activation function. Like we are getting some value, like we are getting, let's say 5 for the input of one neuron, and when how you will get the output? You will get output after putting any of the 4 activation functions. So if here you will put, what you have to do is 1 by 1 plus e to the power minus alpha. Alpha is a constant that will be given to you, and into 5. So when you will do this, you will be getting this O1. Similarly, you can get this O2, O3 and ON. So this type of network is known as single layer feed forward neural network. So single layer, you can see there is only one layer of neuron. Feed forward. Why it is called as feed forward? It is called as feed forward because our information is going in a forward direction. Like our information is going from here to here and here to here. So it is going in a forward direction. All the layer, for all the neurons, you can say similar thing. Information is only traveling in a forward direction. So that is why single layer feed forward neural network. And the thing is multi-layer feed forward neural network. Now here we have dealt with only one layer. But what we in multi-layer feed forward neural network, what happens is we have more than one layer. So this first layer is known as input layer. Then we have a second layer, we call it hidden layer. And then we have this output layer, and we call it output layer. So in a simple multi feed forward neural network, we have 3 layers. First layer is input layer, second layer is hidden layer, and third layer is output layer. Also what happens is that in complex multi feed forward neural network, this we can have more than one hidden layer. Okay, so this is the thing. And feed forward, again this information is traveling only in forward direction. That is why feed forward. Multi-layer because we have more than one layer. In fact, we have 3 layers: one input layer, one hidden layer, and one output layer. So this is known as multi-layer feed forward neural network. We have the third type of neural network known as recurrent neural network. So recurrent neural network, it is similar to multi-layer feed forward neural network. Only difference is that here here in the first case as well as in the second case, we have seen the information is only traveling in forward direction, but this did not happen in this third case. Here the information also travel in backward direction. Here you can see the information from this input is going to here, but after this, what you are seeing, this information is again traveling back to here. So it is not a feed forward, it is recurrent neural network. So that is why it is called as recurrent neural network, because it is the information is not only passing in forward direction, but the information is also passing in backward direction. So that is why recurrent neural networks architecture. Another thing is that the information can travel in backward direction from any of the layer. Like this layer, first layer, it can't, but your information can travel in backward direction in the hidden layer also, as well as in the from the output layer also. So these are the popular 3 type of neural network architecture. So is that clear to all of you?
Yes, sir. Clear.
Okay.
Sir, one more question, sir.
Yes.
Sir, actually, we have the different layer formation.
Yes.
Among these, which one is a very fast we are using for
Which one we are
computation?
using? We are basically
Very
using
fast, fast.
Fast.
Speed of operation. Yeah.
Yes. The fast is multi-layer feed-forward neural network, right? Because what happens is you single-layer feed-forward neural network only has one layer. So it what happens is time complexity of this increases very fast. So that is why multi-layer feed-forward neural network is the most popular one, as it is very fast. Okay. And during training, during the next class, during training also I will show you that why this multi-layer neural network is very fast. Okay.
Okay, sir. One more, sir. In different transformation,
Yes.
which one is we are going to normally apply?
Okay, this is a good question actually. So what happened is that we use this transformation function according to the complexity of the problem. So in input layer, what happens is we do not require more calculation, we do not require more complexity. So that is why in the input layer basically we use out of this two we basically use, right, this first one as well as second one, that is hard limit transfer function, signum transfer function. Basically this two we use. But in hidden layer what we do is we process complex information. So that is why for hidden layers we generally prefer this tool like log sigmoid, tan sigmoid, or even Gaussian function is also there if you will study the hard things. So that is why hidden layer we prefer complex transformation function. In input layer we prefer simple transformation function, and output layer also we generally prefer simple transformation function. Output layer actually you can go with both, like you can also go with simple transformation function as well as complex transformation function, but input always we prefer simple transformation function, and hidden we prefer complex transformation function. Okay.
Okay, sir. Thank you.
So now we will be discussing the assignment questions. So your assignment question is based on all these topics. As this is last class someone was asking that is this assignment questions the assignment question that you are solving. So the answer is no. This assignment question is similar question that you are solving in your assignment. My job is to my job is to get you practice some question that are very similar to your assignment question, but the assignment question you have to do on yourself. I will be what I will be doing is I will be solving very similar question that mimics your assignment question, so that whenever you will be solving your assignments or whenever you will be giving the exam, that time that concept will be more clear. Okay.
Okay, sir.
Okay. So now I will be discussing all the question. I want all your activeness, so kindly please participate in the discussion. You can I will be asking the question, and what you will do is you can guess the answer in the chat box. So by that I will be understanding that you are getting something. Okay. Is this okay?
Okay, sir.
I want this class to be a bit interactive when I am discussing the questions. Okay. Okay, so this is the first question. Consider a two objective optimization problem where one of the objective function f1 needs to be maximized and the other objective function f2 needs to be minimized. 5 candidate solutions are given, 1, 2, 3, 4, 5, and 5 in the solution space of this problem, and which of the following is correct? You have to determine that. So option A is solution 1, 3 form a non-dominated front. Option B is the best non-dominated front is 2. C is the ordering of the solution fronts in terms of their non-domination level is 2, 4, 5, 1, 2, 1, 3. D is the ordering of solution front in terms of their non-domination level is 3, 5, 1, 4 and 2. So anyone who want to guess which of the 4 out of is the correct answer? Any guesses? You can write in the chat box. Any guesses? A, B, C or D? Okay, Murugeshan is telling D. Yeah, Sadasiva Pradhan is also telling D. Okay, so let me tell you the solution. So let's check the first statement, that is solution 1 3 form a non-dominated friend. So where is 1 3? So let's see what we have to do with our objective problem. F1 we have to maximize. So our most non-dominated point should lie somewhere here, and F2 we have to minimize. So our most dominated point should lie here. That is, if we draw an ellipse over all this point, our non-dominated friend should lie in the first, second, third and fourth quadrant. So either this will be your non-dominated friend, this will be your non-dominated friend, or this will be your non-dominated friend. So let's check one by one. So first thing is telling 1 3 form a non-dominated friend. So that is absolutely not correct, because your friend will be forming like this, either 2, either 1 4 or 3 5. If we compare 1 with 3, here you can see that we have to maximize F1. So if we want to maximize F1, so 3 is the point that is satisfying. Also we have to minimize F2. Minimize, when we are minimizing F2, in that, let me erase it first. Okay, so we are comparing 1 and 3, right? So 1 and 3, when we are comparing, 3 is greater than 1 in F1 and 3 is less than 1 in F2. So third point is dominating point 1. That is the statement. But 1 3 does not form friend. 1 3 is not forming friend, because if we, let's say 1 3 is forming friend, so a friend is only formed when these 2 points neither dominate one another. But here we can clearly see that third point is dominating over this first point. So first statement is not correct. So let me erase this. So first statement is not correct. Now what about the second statement? The best non-dominating friend is 2. So yeah, 2 is forming a friend, that is true. But see, the problem with 2 is that we have to maximize F1 and we have to minimize F2. But 2, you can see this second front, or if I can say it front, let's say this is as front 3, this is front 1, this is front 2, this is a front, and this is a front, right? So this is a front 3. So if I talk about the front 3, that is point 2. First of all, one point cannot form a front. Front is always formed by locus. But let's say that there are other points here also with 2. So here we can see that we have to maximize F2, F1, and we have to minimize F2. And here you can see that this second point is not satisfying F1, because we have to maximize F1, and this second point is the smallest among all the 5 points. So it is not satisfying objective 1. And objective 2, we have to minimize F2. So again our point 2 is greater in all the F2 objective functions. So again this is not satisfying. So that is why second is not the best non-dominated friend. So this is also not the correct answer. Now see, the ordering of solution front in terms of the non-domination level is 2 4 5 1 3. Now again you can see 2 4 5 is not forming front, 1 4 is forming a front, 3 5 is forming a front, but 2 4 5 is not forming a front. So ultimately this is also wrong. And D, the ordering of solution front in terms of the non-domination level is 3 5 1 4 and 2. Now I have told you the best rank is given to the most non-dominated front. So most dominated non-dominated front is 3 5, because it is, if we are drawing a ellipse like this, so it is at the extreme end of the ellipse and in the fourth quadrant. So 3 5 is the most non-dominated front, followed by 1 4 and followed by 2. So answer D is your correct answer. Okay, so is this clear to all of you?
Yes, sir.
Okay. Now let's move on to the next question. Non-dominated sorting algorithm NSGA is based on the concept of niche method only, non-dominated sorting procedure using a ranking selection method only, non-dominated sorting procedure using a tournament selection method only, non-dominated sorting procedure using using rank selection and niche method. So which of the four is correct? Any guesses? Any guesses for this question? Yeah, Murugesh is telling D. Any other guesses?
Yes, sir. D.
Okay. Yeah. So NSGA I have discussed in the first slide only. So NSGA, what we do is we do the ranking first, right? We first do the ranking and then we find out the niche count by the sharing function. So so here also you can see that this has been asked in the question, that non-dominated sorting algorithm is based on the concept of niche method only. So this is not correct. Not only niche method, it is based on niche method, but it is first based on ranking selection of the non-dominated front. So that is why option D is the correct. What about option B and C, non-dominated sorting procedure using ranking selection only? So here niche method is not mentioned, so this is also wrong. Non-dominated sorting procedure using a tournament selection only. I have told you we do this by ranking selection selection of the non-dominated front. So this is also not true. So that is why option D is the correct answer. Okay, is this clear to all of you?
Yes, sir.
Okay. So question number 3. Suppose in a MOOP there are m different objective function. Initial population, the NSGA2 is utilized to solve MOOP. The time complexity of crowded tournament selection procedure in this case is. So any guesses for this? This you can study more in your lecture note. This is a very direct question from your lecture note. So any guesses? A, B, C or D? Okay, Murugesh is telling D. Any other guesses? Any other option that you believe is true? Okay. So yes, in NSGA2, when you are doing this crowded tournament selection, the scientists have done all the research and they have found out the time complexity in this particular crowded tournament selection is mn log n. Now what is this m? M is the number of objective function, n is the number of population, and then log n. So this is the time complexity. So this is a direct question. I am not explaining anything. This is time complexity of the operation. This is taken from your lecture note only. So that is mn log base 2 n. So this is the time complexity. So this is a direct question. So answer is D. Now in NSGA, dummy fitness values are assigned to each individual solution belonging to a particular non-dominated front. These dummy fitness values are usually option A, very less and inversely proportional to population size. Option B is very small and proportional to total number of objective function. C is very large and proportional to total number of non-dominated front. And D is very large.
So D, very large and proportional to the
population size. Okay. So any other guesses apart from D? So I think yes. So yes, absolutely, the dummy fitness value is a very large number and is typically proportional to number of population. So answer D is your correct answer. Okay. So let's move on to the question number 5. As per crowding distance comparison, which of the following statement is correct? Option A is a solution xi is selected over another solution xj if dominance rank xi is less than rank xj. Then B is a solution xi is selected over another solution xj if rank xi equals to rank xi and crowding distance of xi di is less than crowding distance xj dj. C is a solution xi is selected over another solution xj if rank xi equals to rank xj and crowding distance xi di is greater than crowding distance xj dj. And D is none of the above. So any guesses for this? Which one of the following statement is wrong? Here you have to find out which one of the following statement is wrong. So any guesses for this? Yeah, Murugesh is telling B. Any other guesses?
Sir, I think also B is the wrong.
Okay, you are telling B is wrong. Okay, so let's check one by one. Sorry.
It may be less than rank xi is less than.
Okay, so let's see this. A solution xi is selected over another solution xj if dominance rank xi lesser than xj. So this is absolutely true. In the first slide only I have shown you that we are doing this ranking thing, and how selection pressure is ensured. Selection pressure is ensured by getting more copies of more copies of points that have lower rank than more copies of points that have higher rank. So here you can see the more copies will be of rank 1 than more copies of rank 2 and 3. So that is why first statement is correct. That is, what was our first statement? Here. Okay, this solution xi is selected over solution xj if dominance rank xi lesser than xj. So this is absolutely correct, right? Now a solution xi is selected over solution xj if rank xi equals to xi and crowding distance di lesser than crowding distance dj. So we know that if we are comparing in a same rank thing, and in our example also I have shown you this first point 1 and 5, right? These 2 points are actually very far from other points, and here we have 1 point, here we have 1 point, here we have 1 point. So 2, 3 and 4. 2, 3 and 4 are very close to each other. So this 1 and 5 point, as they are very far from each other, they have more crowding distance. So solution 1 and 5 will be selected over 2, 3 and 4. So here also you can see this, that if we are comparing in a single rank, that is rank of xi equals to rank of x, actually this is xj. This is a printing mistake, this should be xj. Okay, if rank of xi equals to rank of xj and crowding distance xi di lesser than crowding distance dj, so xi should be preferred. So no, this is a false statement, right? The crowding distance, the crowding distance should be more for the solution to prefer. We are preferring here 1 and 5 more than 2, 3 and 4. So the point which have more crowding distance, we are preferring that. So this is a wrong statement. Let's see the C statement. A solution xi is selected over the solution xj if rank of xi equals to xj. That is true, and crowding distance of xi di is greater than crowding distance xj dj. So this is a true statement that I have already explained you. Like as the crowding distance of first point and fifth point are greater than crowding distance of all the other points, so this point is are selected over all the other points. So this is a true statement. So as here we have to find out the wrong statement. This B is the wrong statement. So answer is B. So is this clear? Is this thing clear?
Yes, sir, clear.
Okay. So let's move on to the sixth question. Which MOGA technique or multiple objective genetic algorithm technique uses crowding distance to select a better solution? This I want everyone to guess this. I have discussed many times.
Yes, sir. NSGA-2. So
Okay, and
we answered this.
okay, the answer. Any other guesses? Anyone with any other guess or wants to say anything? Okay, so this is a direct question. So I have told you that in NSGA-1 we were using the sharing distance concept. But what happens in sharing distance is that we have to first calculate the sharing distance, then niche count, and then sharing fitness. So it is a three-step process. So we are replacing the three-step process in one-step process by replacing the sharing distance with crowding distance. So answer B is the correct answer, NSGA-2. Okay, this is a direct question, so I think no problem will be there. Now let's move on to the question number 7. Which of the following appropriately describe the niche count of a particular individual xi? So first is it's a quantity that is proportional to the number of individual around xi in the current friend. B is it's a quantity that is inversely proportional to number of individual of xi in the current friend. C is it's a quantity that is proportional to rank of the friend to which xi belong. And D it's a quantity that is inversely proportional to rank of the friend to which xi belongs. So any guesses for this? Any guess he wants to make for this question? Question number 7. Am I audible, guys?
Yes, sir.
Okay, so any guesses?
Sir, I think option D is correct.
Option D. Any other else? Anyone else with other guesses? Okay, I
So
think
B or D.
Murugeshan is telling B or D. Okay. Okay, so let's check. So first statement is telling it's a quantity proportional to number of individual around xi in the current friend. So first of all, when we are talking about niche count, we are only talking about a particular friend. So this thing you have to take in account. So as we are talking about the particular friend, so it should be out of A and B. It should not be C and D. So C and D are wrong, because here it is telling about different friends, and here also it is not mentioning friend. So about A and B, this quantity is proportional to number of individual around xi in the current friend. So let's move on to our question, and let's see here what is now here niche count of this point 2, 3 and 4. What is coming? Niche count of 2, 3 and 4 are coming 2.24, 2.26 and 2.24, right? And we can see that this 2, 3 and 4 are more crowded, right? So niche count is proportional to number of individual around the solution in the same friend. So your option should be your option should be is quantity proportional to number of individual around the current front. Your option should be A. Okay, is this clear? It is not B, because it is telling inversely proportional to number of individual around the current front. So no. You can see the question I am drawing here. 2, 3 and 4. This point have niche count of 2.24, 2.26 and 2.26, right? But point this and this has niche count of 0.72, right? So niche count of 0.72 for this 1 and 5. So I am writing here 1 and 5 niche count was 0.72, and 3, 3, 4, 2, 3, 4. 2, 3, 4 has niche count of 2.24 or 2.26 approx, right? So let's take it 2.25. So niche count of this 3 point was approximately 2.25, and niche count of 1 and 5 was 0.72. So that means as 1 and 5 were not surrounded by that many individual, so that is why niche count was less for this two. And 2, 3 and 4, they are surrounded, they were closely crowded, or they were surrounded by more individual. That is why niche count of 2, 3, 4 were more. So that means this is the right answer. Its quantity is proportional to number of individual of xi in the current front. So A is the correct answer. Okay. So any doubt?
No, sir.
Okay. So you were confused about B and D. B is not true because here it is telling inversely proportional. It is not inversely proportional. If we were telling about shared fitness, so there it is inversely proportional. Okay, but
Okay,
when
sir.
we are talking about niche count, it is directly proportional. And this D cannot be true because here it was telling about rank of friend, and niche count is only applicable to a single friend. So that is why D is not correct. So your answer is A. So let's move on to the next question. Which of the following multi-objective evolutionary algorithm is based on the concept of elitism? So any guesses for this? A, B, C or D?
Same, sir. Jo NSGA 2.
NSGA 2. Okay. Any other guesses? Murugation is telling
B,
B.
sir.
Okay. So concept of elitism. Okay. Yeah. So let me tell you elitism. So what is this word elite means? Elite means the solution should be good with respect to all other solution. Elite. We basically use this term like this. The family is very elite, or they are some elite group of people. That means the solution should be good with respect to other solution. And here we see that one of the disadvantages of NSGA is that it is based on non-elitism, that the solution that NSGA give are some of the solution as non-elite. So that is why we move on to the NSGA 2. So NSGA 2 is based on elitism. So correct answer is D. So you can also read in your next lecture note is that these are the disadvantages of NSGA 1. So here you can see NSGA 1 is a non-elitism approach, and to counter all these three disadvantages of NSGA 1, we have developed this NSGA 2. So NSGA 2 is based on the concept of elitism. So answer option D is your correct answer. Okay.
Okay, sir.
Okay. So question number 9. This the range of hard limit transfer function is. So I want you to guess this because I have shown you the transformation function, and we here it is telling hard limit transformation function. What are the limit? What is the range? So I want all to guess this. I have already shown you the graphs also, and also the transformation function also. So here it is asked about hard limit
0
transfer
to 1,
function.
sir.
0 to 1. Okay. Any other guesses?
Yes, sir. 0 to 1.
Yes. Okay. Okay. So yeah, very right. Hard limit function. Its range is from 0 to 1. This is the 0 and 1. When your output or the output from the, or you can say the summation of input, let's say it I, let's say it I1 is coming to be less than equal to theta, that your output will be O will be 0, right? And when your I1 will be greater than this theta, your output will be 1. Okay, so this type of function is known as hard limit transfer function, and range 0 and 1. I hope this is clear. Okay, so this
Yes, sir.
answer is
Sir?
B.
Sir, why this name?
Yes,
Sir,
yes.
why this name is called hard limit? Why this name is called hard limit?
Yeah, hard
The word
limit.
is hard. Why it is hard?
Yeah, hard limit means I think it is because it is giving you only two limits, that is 1 and 0, right? Because the means after this threshold it is given 1, and before this threshold it is given 0, right? This theta, let's say it is a threshold value, so after this threshold it is giving 1, and before this threshold it is giving 0. It is not giving you 0.5 or -1 or something, no value if it is lesser than your threshold. That is why I think it is known as hard limit transfer function. Okay, means
So
Okay,
also linear is also -1 to +1.
yes, linear is -1 to +1, right? Not 0. Okay, -1 means there is some value, some output value, not 0. Okay.
Okay, sir.
Okay. So which of the following function is known as tan sigmoid transfer function? So guesses for this also I have shown you. Any guesses for this? Question number 10. Again I am repeating the question. Which of the following function is known as tan sigmoid transfer function? Yeah, Murugesh is telling C. Any other guesses? C or D? Okay, so yeah, this this is for you could confuse between C and D, because C and D are very similar, but always remember that it is C, because what happens is that most of your transfer function will give you a value less than 1. So you can see the value for this is less than 1, whereas if you will keep plus in numerator and minus in denominator, your value will be greater than 1. And there is a concept called scaling. Scaling means you have to fit your output in a very small value. So for this, most of your transformation function will give you a very less value, that is most it give less than 1. So that is why answer C is correct. So that I have told you, you could have confused between C and D, but C is correct. Okay, this is the thing. So question number 11. Typically a human brain consists of 10 to 11 neurons communicating with the help with each other with the help of A is chemical reaction, B is red blood corpuscles, C is via varying magnetic field, and D is electrical impulses. So any guesses for this?
So I think electrical impulse.
Yes. Any other guesses? Sonali is telling A. Okay.
D is electrical impulse.
Okay, D. Okay, Sonali is telling, now she is telling D. Okay. Okay, so yeah, whenever I was explaining you the analogy between this artificial neuron and biological neuron, I have told you the information will be passed to the next neuron whenever it will be greater than a particular voltage. So that voltage is created by this electrical impulse. So answer D is your correct answer. This is a biology based question, but as we are discussing the neural network, this question could also be asked. So this is the thing. Okay, so answer D is the correct answer. Now question number 12. Single layer feed forward neural network is used to represent AND logic for two inputs as shown in the figure. So these are the two inputs, x1 and x2. The weight for x1 is w1, the weight for x2 is w2, and b is a term called bias. So bias is given after this summation of this. So the summer block computes the summation x1, x2 and the bias. So I have told you how output is calculated. Output is calculated by x1 w1 plus x2 w2, and I have not told you about bias. So what happens is that some of the let me show you this pen. some of the okay, yes, your transfer function can be 1 by x. If this is a transfer function you are designing, and you are getting after summation you are getting a value of 0, like w1 sorry, w1 w2 cannot be 0, like x1 is 0 and x2 is also 0. So in that case what happens is you, as you are programming an artificial neural network, your result will be 1 by 0. So 1 by 0 is a indeterminate term, so you cannot determine 1 by 0. So that is why what we do is after this sigma x I wi, what we do is for this not to be happen, what we do is we add a bias value. So that is why when we are adding the bias, if this value is also 0, we have some value here, so our neural network will determine something. So that is the concept of addition of bias. So here what has been asked in the question, which of the following weight and bias value set is not valued for AND implementation? Yeah, so this is your AND implementation. In AND implementation what happens is that AND implementation we know that in all the three sets, that when the inputs are x1 x2 is 0, x1 is 0, x2 is either when either any of the x1 and x2 is 0, we get 0 as output, but when both the inputs are 1, we get 1 as output. So when we are designing this AND problem in a neural network, we have to take care of this last step. Last step is when we have these two inputs, and when we are multiplying by the weight, we should get something, not 0. So that will be our answer. So here it is asking that which of the following weight value is not valid, means which of the 4 are wrong. So let's check this first one. First is w1 is 0.5, so 1 into 0.5 is 0.5, plus 1 into 0.5 is 0.5, plus bias is minus 0.9, so 1 into 0.5 plus 1 into 0.5 minus 0.9, that is coming 0.1. So this is true, because some value is coming and not 0 is coming. So this is this A option is correct, and we have to find out the wrong statement, right? Then B is w1 is 1, w2 is 1. Now in neural network I want to neural network, what happens is when you are multiplying w1, 1 into 1 plus 1 into 1 minus 1.5, so that is 1 into 1 is 1, 1 plus 1 is 2, minus 1.5 is 0.5. So this is also can happen for this AND implementation. Now this 1 into 2 plus 1 into 2 minus 3, now it is coming 1. This can also happen. But what about D? D is 0.1 into 0.5 plus 1 into 0.5 minus 8, that is 0.5 plus 0.5 1, minus 8, minus 8 is minus 7. So this can't happen, right? Minus, it is coming in minus, and we know that AND implementation, your output should be between 0 and 1, and it should be not 0. So this minus 7 could not happen. So this is also true. This is the false statement. So answer D is your correct statement. Okay, is this clear? Why D is not possible? D is not possible because the answer is coming minus 7. It is not between 0 to 1, and it is coming in negative. That is why D is the correct answer. Okay, is this clear?
Okay, sir.
Okay.
Yes, sir. Yes, sir. Okay, sir.
Okay.
Yes, sir.
Okay. So question number 13. Which of the following statement is correct about neural network implementation of and XOR logic? So and logic, you have seen this. And what about XOR? Let's form the truth table of XOR. XOR is not of or. So let it be x1 here, and let it be x2 here, and this is or, this is the for or, and this is for XOR, right? So again 0 0 1 1. Sorry. 0 0 1 1 and 0 1 0 1. Okay, these are your inputs, right? And or what happens in or is your output will be 0 when both the input are 0, otherwise your output will be 1. So this is 0 0 1 is 1, 1 0 is 1, 1 1 is 1, and XOR means it is not of or, that means 1 0 0 and 0. So this is how your XOR is made of. And I have already shown you here 0 0 0 1 1 0 1 1. Your output will be 1 only when both the inputs are 1, otherwise your output will be 0. So this is XOR, and the previous one was AND. Now what has been asked in the question is both AND and XOR logic can be implemented by single layer feed forward network. Now this AND can be implemented by your single layer, but your XOR cannot be implemented by a single layer feed forward network, because you can see here we are after this OR we are putting another column, right? Up to OR we can do by single layer feed forward network, but when we are adding, we have to add another layer to find out XOR. So this is not correct. Can be implemented, none of the AND and XOR can be implemented by a single layer feed forward network. We know that AND can be implemented by your single layer feed forward network, but XOR cannot be applied. So this is also a false
So
statement.
C will be the correct
A
answer.
single layer feed forward network is sufficient for AND logic, but XOR, yeah,
So
C is your
C.
correct answer. Both requires multi. D is also wrong, because AND can be solved by single layer feed forward network. So C is the correct statement. Is this clear? XOR and
Sir,
how?
what?
Yes, yes,
Sir,
yes.
what about not gate? Not logic.
Not gate. It can be with one layer only. Not is 1 0, right? Not is for not. Let me erase this.
Sir, all the basic gates can be solved from, using the single layer feed forward network, right?
Yes, yes, yes. That is and or and not. That can be solved by your single layer feed forward network. And
Single
when
feed
you are
forward network.
going with XOR and that NAND, then you have to
Com
yeah, you have to use.
Combinational gates.
Yes,
In
yes.
combinational gates, you have to use multiplayer feed forward
Yes,
network.
yes, yes, absolutely. So someone was asking about Murugeshan was, I think, asking about not, right? Not. We have two inputs, 1 0. So this let be your input xi x1, let's say, and we have to find not, right? No t. Not is 0 and 1. This is the thing. So when you are giving 1, you will be getting 0. When you are giving 0, you will be getting 1. So that can be done by your single layer feed forward network. Okay, Murugeshan?
Okay.
Okay,
Okay, sir.
okay.
Sir, one more question, sir. Sir, if I am doing for my first two iteration, I getting some error. I have some weight. If I am going for the second iteration, I want to increase my weights or decrease weights.
Yeah, that question will be answered in the next class when we will be doing that training part, training of neural network. Okay. Okay,
Okay,
Murugeshan.
sir. Okay.
Next class. So yeah, let me
Okay, sir.
let me
Okay, okay.
tell you by very brief. What happens is there is a learning rate. Learning rate we do with error, de by by dw. Basically what we do is we form a graph of this output with your weights, sorry, not output, error with your weights, and let's say your graph should be like this, right? So if you are here, right, so if you will increase the weight, then your error is increasing, so in that case you have to decrease the weight, right? And if you are here, so if you will increase the weight, your error is decreasing, so you have to decrease the weight. So this is the concept. In very brief I have told you. Next class what we will do is we will be solving one numerical. In that I will show you how this is done. Okay, am I audible?
Okay, sir. Okay, sir.
Okay.
So basically, we are minimizing the informations in the next iteration, right?
We are
When we are
minimizing the
decreasing
error, not information. We are minimizing the error.
yes, so error.
Yeah. We are
Okay.
basically what we are doing is forming a error graph with weight. We are forming a relationship of error with the weight. We are checking at which point how this term is behaving. This is your learning rate. This is learning rate means how much you are varying. Like I will say, after this point I should be taking very close point, or I should be taking very far point. So for this we use this learning rate, and del E by del W we are checking of relationship of error with weight. Okay.
Okay, sir.
Okay, so let's move on to the next question. Which of the following statement is true for single layer feed forward neural network? A maximum of 2 input and maximum of 1 output is maximally supported. B is multiple inputs but maximum 1 output is maximally supported. C is it can have multiple inputs and multiple outputs. D is it consists of multiple hidden layer. So any guesses?
Yes, sir. A.
True for single layer feed forward network. So let's check A. A
Yes.
maximum of 2 input and maximum of 1 output is maximally supported. This is absolutely wrong. Multiple input but maximum 1 output is supported. This is also not correct. It can have multiple inputs and multiple outputs. So this is the thing. So this is the correct answer, and multiple hidden layer as it is a single layer feed forward network. This also can't be true. So answer is C. Okay, multiple inputs, multiple outputs. Okay, and only one layer of input. That is the main thing. Not
Okay,
more
sir.
than one layer of input. So this is very simple, I think. Okay, Sonali, A is not correct because it is 2 input and maximum 1 output. So no, we can see here we can have many input as well as we can have many outputs. But only the thing is we have to take one layer of neurons. Okay, layer 1 but input output more. Yes, one layer of neuron and more input output. Yeah, right. So question number 15, what is soma? It is a junction where axon contacts the dendrites of neighboring dendrites. It is also called cell body, and just like a nucleus of the cell, a long cylinder fiber, a bush of thin fiber. So anyone who wants to guess this?
So it is also called a cell body.
Yeah, very nice. Any other guesses? Anyone who wants to contradict this statement? Yeah, B. Okay, very nice. So yeah, I have told you this nucleus of the cell body. This is known as soma. Bush or very thin fiber. These are known as dendrites. Long cylinder fiber. This is the axon. Junction where axon contacts with the dendrites. So no, this is a synapse thing. Synapse is where you are getting that electrical impulse. So this is also not correct. So this is also not correct. This is axon. This is axon. And this is dendrite. Okay, so this is axon, this is dendrite, this is soma, and this is you can say this is the synapse thing. Okay, so option B is your correct answer. Is this clear? Is this thing clear to all of you?
Yes, sir.
Yes, sir.
So any doubt regarding today's class? Anywhere any doubt? Anything you want me to again discuss? This is 7:55. We have more 5 minutes. So anyone who wants to discuss any other thing can please ask.
Sir,
So can
in
we
the last,
discuss about that iteration of neural networks, the increasing and decreasing of the weights,
Yes,
which
yes,
Murugan asked question about? Can
yes.
we discuss more about it?
I will be discussing more about this thing in the next class. Okay? I will be
So
solving.
when the next class was held, because
Yeah, next
26 we
class.
have
Yes,
one
yes,
exam.
yes. Next class will be on Friday. Okay? Friday
Okay,
6
sir.
to
Okay,
6
sir.
to 8 p.m. You will be getting the mail before that, but yeah, I am telling you beforehand that it will be on Friday 6 to 8 p.m. Same time 6 to 8 p.m. on Friday, 24th of March.
sir,
Okay, sir.
Yeah,
sir, I have missed last class, sir. In that you
yeah,
talked about the dominoes. In the dominoes about the reflexivity and symmetry. The partial order, there is some give
yeah.
some
So
explanation, sir.
a video of that lecture I have uploaded in that YouTube channel, as well as when you will open the problem solving session part, there you will be seeing the link. Okay, last class was on 18th. Very few have joined that class. I think, I don't know,
Yes, sir,
there
sir,
could
sir.
be some communication gap also. I don't know
Yes, sir.
what
We have
happened.
watched.
Yes, 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 yes,
Sir,
yes.
watch that video, sir. In that you said that is some partial order, and that is some doubt there. So
Yeah,
we need some
it
clarification.
is not a partial order. Okay, so let me open that. Yeah, 1 minute. Is my slide visible?
Yes, sir. Yes, sir. Visible, sir.
Yes, sir, it's visible.
Okay. Yeah, so what is your doubt, Murugesan? Can you say? Am I
Sir,
audible?
here what is partial order? Yes, sir. Yes, sir. What is the partial and strictly partial order?
Yeah,
That
strictly
is a
partial order. Okay, so strictly partial order means your binary relation is known as partial order relation when it is reflexive, antisymmetric, and transitive. But we can see here is that as our dominance relation is not reflexive. Why it is not reflexive? Because here you can see that when we are comparing a point xi, right, with another point xi, same point xi, so our first condition is satisfied, that is xi is no worse than xi, but xi should be strictly better than xi in one objective. That is not happening, because xi is equal to xi. So that is why our dominance relation is a not reflexive relation. So that is why that is why our dominance relation is not reflexive, not antisymmetric, not reflexive, not antisymmetric, but transitive. And it is only called it is called partial order relation when it is reflexive, antisymmetric and transitive. So that is why our dominance relation is not a partial order relation. Our dominance relation is actually a strict partial order relation. Okay, when it is not reflexive, not antisymmetric but transitive, it is known as strictly partial order relation. Okay, hello, am I audible?
Sir, if it is yes, yes, sir, if it is not reflexive, not antisymmetry, we can
Not
say it is a strictly
when it is not
uh,
reflexive, not antisymmetric but transitive,
and transitive.
we can say it
Uh-huh.
strictly partial order relation. So this you can also
Strictly
study in
partial.
your note
Okay.
also. There is
Okay, okay, sir. Thank you.
not very hard thing about this.
Okay, thank you, sir. Thank you.
So any other doubt apart from this?
No, sir. Thank you, sir.
Okay, so I am
Thank you, sir.
terminating the session for today. We will meet on Friday 6 to 8 p.m. Okay?
Okay, sir.
Okay. Bye all of you.
Yes, sir.
Thank you, sir.
Okay.
Thank you very much, sir.
Okay.